So I'm Gavin Medel-Gleason, and I'm from Data Chemist. I'm the CTO there at Data Chemist, and we're an enterprise knowledge graph. Okay, so how do I flip this thing? There we go. All right, so the graph database world today. Okay, in 300 BC, China was fragmented and cut up into all these different little groupings, right? And then came in Qin Shi Huang, and he united China together into a single unified state, right? So Data Chemist is going to do this, right? We're going to come in, we're going to unify the state of the situation. So right now we have property graphs and we have RDF, and as people in Neo4j have said and others have said, it's possible to actually represent property graphs inside of RDF using disintermediation, reification, these different kinds of techniques. And what's really necessary to make it usable is some sort of query language that is semantic aware and is capable of doing this. So Data Chemist is really based on standards. We think that standards are really important. We use AL, we use RDF, but right now the query languages are sitting at a level that's too low. It's too low level to take advantage of the possibilities that are provided by semantics. So Sparkle is actually sitting at a layer that's just one level below where the semantics are. And it's kind of inverting the situation of SQL, where the schema drives the way that queries are done. Okay, so Data Chemist also has a SaaS platform. And we try to make it easy to use our tools. We try to make it easy to develop ontologies with our tools. We have, you can't see this at all, but it's an import screen there. We have complex ontologies for things like supply chains. We have multiple inheritance. You can do all of the kinds of things that you do in AL. We can automatically allow you to add temporal constraints on things. You can put all kinds of different cardinality constraints on your ontology and build it up very easily, and then dump it out to AL and use it somewhere else or use it with our tools, whichever way you want to do it. And we have a query interface where you can get back graphs very easily, so you can look at what kinds of things are in your database using our query language, WACL. Okay, so our underlying database technology, we're releasing as an open source tool, probably sometime at the end of the summer. And we call it Terminus DB, and Terminus was the god of boundaries. So we want to impose structure on data. That's what Data Chemist is about. So we're going to release it. It's basically an SDK so that people can build out the applications that they need using our technologies. And it has nice interfaces with JSON LD. It's RESTful API. It's very straightforward. Okay. So some of the things that we're good at in Data Chemist, temporal scoping is one of the things. We use temporal constraint logic. So in our queries, with WACL queries, you can do time slices through multiple relationship chains very easily. And we think that's a really powerful feature that's needed in a lot of different aspects. And in WACL, we return, not only do we have tables as a return element, we also return graphs. And we have recursive queries so that you can do complex, non-regular chains, etc. And we can also do weighted edges and minimization algorithms using our language. And I would just like to submit to you that recursion is not just a nice to have when you're dealing with graphs, it's actually a must. So dealing with the recursive questions is fundamental, and we're going to need it in the query languages of the future. Thank you, Data Chemist.
My name is Jeremy Hanna. I've been at Datastax for about 7 years now, in the Cassandra community as a contributor to the project for about 9 years now. I'm something odd title, Vanguard Solutions Architect at Datastax. That just basically means that I'm an escalations person for the field and an intermediary between the field and the engineering organization. So a few years ago, when Datastax jumped into the property graph space, I worked a lot with the pre-release customers and all along the way to try to make sure they got everything they needed. Datastax Enterprise Graph, you could think of it as a property graph built on and in Apache Cassandra. The reason for that is because there's some inherent nice properties that you don't want to have to re-implement, such as sharding and scalability. And it takes advantage of all of the nice graph structures as well. Matthias, I think, did his PhD thesis on index-free adjacency lists, and so the storage format is all very optimized and efficient for graph structures. So why people come to Datastax, from what I've found, is just a handful of reasons. Some maybe seem a little bit controversial to some, but scalability, distributed, it's a scalable and distributed by nature. And what I mean by that is there's no special role. There's no leader or failover or anything like that. So if a server goes down in your cluster, no big deal. If there's no special operations for leader election or anything like that. If a data center goes down, no big deal. You have like reads and writes continue as normal. And since it's a masterless design, you can scale out very simply. And so you have, it says billions of vertices and edges. There's no reason why you could go further than that. It's just, that's kind of the order of magnitude that you can easily get to. Like, I do that kind of thing for POCs all the time. So there's the scalability portion. So a lot of the customers that come to us are merging a lot of data in one. And that's one of the strengths of the platform that they see when they come to us. Multi-model, and so sometimes you might have like an energy network, or we have ISPs that use us to have every device on their network come together into the repository, but you might have sensor data that's time series that you want to store in a tabular or more time series form, so you can do both data models within the platform. Standard space interface from a loose interpretation of standards. In the property graph world, Tinkerpop is pretty pervasive. You have Neptune, Cosmos, I believe Stardog and BlazeGraph and others, including Janus, that use Gremlin, and the Apache Software Foundation does a good job in making sure everybody has an equal seat at the table, and that's what I mean by that. I've pushed for more native language features, and then DSLs, so you could do things like medication dot interacts with medication using Gremlin extensions. And then batteries included. I can say, what's my look for my fourth great grandfather whose name was like this within 50 miles of the county down in Ireland between these years, and that can start off your traversal using indexes that are embedded into the graph. Graph frames allow you to easily pull data out of your graph, do data munging, model building, enrichment, that sort of thing, push data back into your graph very simply. And then basic enterprise level security, well, not basic, but anything that you would need for like government, bank, retail compliance, auditing, auth, and transparent data encryption, that sort of thing. So that's kind of where people decide to come to Datastax from a property graph standpoint. If you're interested in learning more, we have a conference in a couple weeks in Maryland. And if you have any other questions, you can hit me up afterwards, but that's about it.
So, my name is Aasman, the CEO of Franz Inc. We build knowledge graphs for a living. Here's two of my favorites. Don't generate much money, but a lot of joy. One of them is for Noam Chomsky. Has anyone here read Noam Chomsky? Yeah? Fantastic. Yeah? 1,000 books and articles and papers, and we're taking all these articles, mostly from the Internet Archive, and then OCR them, put them into triples, and then apply a lot of natural language processing, entity extraction and stuff, and make a beautiful search engine around Noam Chomsky. The other thing is a beauty graph. So a question for the women here. How many, on average, beauty products do you have in your toilet closet? 8, yeah? I'm just telling you. Men have only about 3.5, rising up to 4. It's an industry with $700 billion a year. I mean, it's an amazing big industry. Now, if you go to the web, then you'll find all these beauty products. Every beauty product has 20 ingredients. One ingredient is water, which is safe. All the other 19, yeah. If you look enough in the literature, you will find if you use too much of that, it's very dangerous. So and of course, each of these ingredients has 20 synonyms. Yeah? So this is a taxonomy product where you download stuff from the web and try to create a health score for each ingredient in beauty product. So that's a very cool project. But then here's 2 projects we do for a real living. The first one is a project we do for a company called N3 Results, where we try to make it's an intelligent call center, about several thousand people. Each person went to college. They usually do a little bit of research before they call, so it's not scripting. It's really trying to get into the head of your customer. They work for cloud providers mostly. And what we do is we build a knowledge graph of every company they ever called and all the metadata that they collected about these customers. But also we look at every phone call and chat, and we apply entity extraction for sales terms, for product names, and then we create an intelligence layer on top of that. Very helpful. Then this morning, Barrasa talked about what we did at Multifiore. I would say it's in the top 10 of the biggest knowledge graphs in production. It's really in production. And I'm not going to say anything about it because I want to get to this. Let me skip this. Oh, sorry. Oh, here. Yeah, you wanted a little bit of controversy. So, yeah, we have this thing about knowledge graphs, and I think they really, really need semantics. Yeah. What I usually tell people with relational databases, but for today I changed it into property graphs, is if you ask a relational database or a property graph designer to design an application, there's probably only one neuron in your head that thinks about how it will fit in with the other 200 databases in your company. But if you're in the semantic web community, then the only thing you think about is how does my data set fit in with every other data set that I have. Yeah? It's a huge cultural difference. It's not that much of a technical distinction, but it's more a cultural difference that we have. Okay. And here's a very simple example, the Obama, well, when you want to do the query, what is the median income of the area where Barack Obama was born? Yeah? I can do that query by talking to DBpedia, GeoNames, and census. I don't have to do any integration. Yeah, I can just do one Sparkle query and get the results. Yeah, just one Sparkle query where I talk to 3 databases at the same time. And because some people in completely distinct places really cared about using the same name for the same thing, this all worked. Yeah? So that's about the culture of the semantic web. And that's the culture you need to have to build knowledge graphs. And then finally, it's all about scale. Yeah? There's so much data in, say, a hospital. And we're working hard on a new architecture that is now in beta. So if anyone wants to try out to work with the sharded version of an RDF graph database, please come to us and we'll help you do your first POC. Okay, thank you.
So I'm Mike from Stardog, one of the other vendors you haven't heard from today, I guess. Walk softly and carry big bark. We've powered some of the production systems people raised their hand for. Myself and the rest of the founding team have been doing graph, AI, semantics, databases for a long time. It's something we're very passionate about, and we've been bringing that to the Stardog platform. And what are we using it to solve? You know, it's a sentiment that we've heard a lot over the last 2 days. Enterprise data is messy, it's in silos, it's hard to access. And because it's hard to access, it's hard to use, and that's really what all organizations are focused on. How do we use our data? How do we leverage it? How do we monetize it? How do we do cool stuff with it? There's many different ways that takes shape, but it's kind of the big hurdle. This is the big problem that vexes enterprises. And sadly, it's not getting any easier. You know, people fetishize about the big V of big data, volume. Not that interesting. The hard one's variety. You know, that's what we saw on the previous slide. All those different places and ways organizations store data. That's where our customer 360 information is stored. We're trying to do AML, everything we need to know about the transaction. So it's transaction 360 that's stored across the enterprise in all of those different places. So accompanying that crazy volume growth is crazy variety growth. It's not just homogeneous data. And you know, this is where organizations really struggle. And this is where, you know, people have talked about this a lot too. Ontologies, logical models, data models, however you want to frame it, you know, this is the way that we need to start thinking about and talking about our data in our organizations. So, you know, our belief at Stardog is, you know, one thing, these production systems that carry all that data aren't going away, but ETL is kind of, the old school approach. Someone was talking about this yesterday. Like the craziness of ETLing data around and then ETLing again in some other system to be able to make use of it. Connect the data where it is in place, but leverage the time that you take to craft that ontology or logical model or data model, however you want to think about it, and apply that over the data. That becomes your lingua franca for your business, and you start being able to access your data, talk about your data, use your data in the terms of the business. So products, people, purchases, SKUs, transactions, the things that really matter. And the distinctions of keys and values and nodes and edges, even rows and columns, none of that actually matters. It's using your data in the way you think about your data. And that's what we at Stardog are trying to enable. It's an approach that's worked for a lot of companies. I'll leave this here. There's always one I'm proud of. From Apple to, we have a lot of our friends in the finance industry, so a lot of work we've been able to do in the banking industry, to public institutions with important missions like NASA and the National Cancer Institute. We're a DC company. So we've been excited to be a part of their missions and helping them move forward. Variety of use cases, as you could imagine, seeing where our customers are, a wide variety of verticals, but these are problems that vex everyone. Customer 360 is the canonical one, but everything boils down to that complete view, that 360 view, and it's hard to make that view when your data's spread all over the org. It's in every technology ever created, moving at every speed, so you have to be able to access it, to be able to monetize it and use it appropriately, and that's what we're trying to do. So the Stardog Advantage, marketing added this in. I think I have a minute left, so I'll roll with it. Graph, we probably all agree Graph is more flexible. It's the universal data model. It's just going to be the model for the enterprise going forward. Relational is past its peak. It just hasn't realized it yet. We're probably the only platform that has a mix of materialization and virtualization. We don't actually care where your data is. Use Cassandra. It's a pretty darn good system. So if you got it running in production, just overlay Stardog on top of it and be able to power that production application that Cassandra already powers, and then be able to put that data into your knowledge graph and use it alongside all the other information in the organization. And we're pretty good at reasoning. That's where our pedigree originally was. That's our research back in the days when we were still in college trying to figure out what the hell to do with all this technology. If you want to learn more, Stardog's on our website. Go grab it. Plenty of white papers, tutorials. If you don't want to use Stardog, we still have a Sparkle walkthrough. Go learn Sparkle. There's about half the audience that hadn't learned it. I agree with Jans. Everything needs to be semantic. If you don't want to use Stardog, that's fine. But at least get on the right side of the fence. So go Team Semantics.
Okay, so this is, I think I already said I've been doing this long enough to know that I don't know everything. So this is kind of, my background all the way from sort of DARPA days before the semantic web, now into Amazon. As I said earlier, customers are really excited about Graph. They want to build Graph applications. They want to use relationships. They want to make linkages. They want to solve problems. This is our annual reInvent conference this year. Favorite launches. This was a sort of a Twitter vote feed. And so there's a lot of enthusiasm out there for Graph applications, for processing graphs. Lots of use cases. But when customers think about Graph, they think about something that looks like this. They think about how they make relationships between whatever the key entities that they view in their business are. They're not thinking about this, right? We are. We're thinking about it. We understand that there's different trade-offs, and that if you choose property graph, you're going to have to address these things, and if you choose RDF, there's other trade-offs there. But customers, at the end of the day, they want to build knowledge graphs with both models, and there's lots of factors that go into why one particular model is right for a particular organization or not. You need to go into it with your eyes open. You need to understand what's important about your application. What level of semantics do you need? What level of semantics do you want? At Amazon in general, we talk about one-way doors and two-way door choices. And you need to understand the technologies enough to understand, are you limiting something to do in the future? But at the end of the day, if you want to build a property graph knowledge graph, or if you want to build an RDF knowledge graph, we want to give you the right tools to help you to do that and do it in the best possible way. So this is sort of just an overview of our platform. I showed this slide earlier. Again, Neptune provides support for both RDF and property graph models. We support both of them with an optimized query execution. Today, we do not provide interoperability between the models. It's something that we're really interested in doing. There's a couple of small reasons in terms that we don't do that, and we're working kind of with the community to work through those and try and find a sustainable way to do it. But we think that's pretty exciting. And then the fully managed aspect, we sit on top of a distributed cloud-native storage layer. It supports graphs of up to 64 terabytes. It scales the storage automatically for you. It makes 6 copies of your data across 3 availability zones. So durability and high availability is built into the system fundamentally. And you choose all of the different sizes and how you manage your operations. So thank you very much.
All right, so I'm still Bryon from Data.world. Hello again. So just give a real quick history of the company. We founded the company in 2015. We're a certified public benefit corporation. How many of you are familiar with that structure? It basically means in almost every way we're a totally normal C corporation, but as part of the corporate charter, we have a public benefit statement that allows us to make kind of fiduciary decisions based on more than just fiduciary responsibility to the shareholders. When we first launched the company for about 2 years, we were not really trying to commercialize it at all. We launched it to an open community. We spent a lot of time building up that open community of hundreds of thousands of users, working with a lot of open data providers to syndicate their catalogs into Data.world so that we would have a body of data to work with. Partially that's because we wanted to help fulfill that public benefit part of our mission and create more awareness, utilization of open and particularly linked open data. But we also wanted to use that as all the user testing and kind of user-centered design work that we talked about before. We wanted to have a body of users that we could do both quantitative and qualitative assessment of features and really kind of understand what actively engaged user data work looked like. But we have this large open data catalog, but the vast majority of our enterprise customers are using us mostly or exclusively for management on their own internal data. It's a cloud-based platform. We do have the ability to do kind of completely single-tenant installations, but honestly, the vast majority of our customers are using our secure multi-tenant SaaS-based solution. Very much a model would be similar to something like Snowflake in the warehousing space. Principles of the company, we want to make it so that the broadest number of people within a company as possible are able to work with, interact with, and get effective use from data. Why is this hard? We think that technology alone doesn't create a data-driven culture. Technology alone doesn't break down data silos. Even knowledge graphs, although it's the right way to do it, and it's the most powerful thing, even that's not enough. You still need to actually engage the human beings who actually know what the data mean and actually understand how your business operates. I'm just going to skip past the screenshots because they're washed out and it's not that interesting. I talked a bunch about our platform earlier anyway. Just want to talk a little bit about, I talked about connecting with folks the way they're working with data. We put a lot of focus into our APIs. Obviously that means Sparkle endpoints because totally in the semantics, you got to do semantics camp, but also other APIs around data management to let folks, so the integrations that you can find on our website are not a closed wall ecosystem. Anyone can go read our API docs, build their own integrations. Lots of our customers do. Built on a knowledge graph, preaching choir, I'll stop. Because things not strings, what it lets us do is through any interface on the platform where we know that a thing is a thing, we show it as a thing and let you dig in and get into the data. I'm sure the reason Juan wanted me on this panel, and so I added in a couple slides on this at the end, we're talking about languages and we're doing something I'm sure is pretty unique for anyone else on the panel. We're totally semantics, everyone should be writing Sparkle, totally agree. That's a long road to get folks there. And what we've observed is the vast majority of data has a tabular structure. And when you bring data in and model it using standards, you can still observe that there is that tabular structure where there is a relation that you can do relational things on. You can still treat it relationally. And ultimately, the people who write Sparkle are all over here, and those are all the people who write SQL, and the giant circle that goes off the page is people who can run someone else's SQL query and modify some parameters. So we've spent a bunch of effort to build a SQL dialect, and it is basically as close as possible to totally standard ANSI SQL. This is not a replacement for Sparkle. You cannot use this on arbitrary graph data. We're not doing extensions to let you do things like recursive traversals. That's not the intent. The intent of this is that since the vast majority of the data that we're touching, virtualizing, materializing actually has that tabular structure, you can actually run the SQL queries that lots of people are familiar with, that lots of tools integrate with, and translate that into the corresponding Sparkle that goes through that query engine underneath the hood. That's it.
Hello. Nice to be in front of you again. So we started year 2000. We are leaders in semantic technology. I started the company as an R&D lab within a bigger entity called Sirma Group, which is now publicly listed. And unlike many of the vendors in front of me, we are sustainable and we are self-sufficient, we are profitable, so we don't burn anybody's money. We have most of our clients in London and New York, and I'm happy to see many of you around. We had the chance to invest a lot in research, so we've been involved in tens of research projects. We work with hundreds of universities, literally. Lots of papers, lots of citations. And we are involved through the years with all the industry bodies which govern the standards that we use, all the way from W3C, EDM, ODI, Linked Data Benchmarking Council, and so on and so forth. So that's probably enough as introduction of who we are. What makes us unique is that we have plenty of vendors in the database space and plenty of vendors in text mining space. But we don't have many vendors that do both of these technologies and know how to synergize them. And to tell you a secret, why we started doing database engine 15 years ago, just because we wanted to do text analysis that uses a big knowledge graph to make better text analysis. And back then, there was no triple store and no graph database which can do this. And we ended up doing a graph database engine which can fit this purpose. This was why we started it all together. With all the fancy stuff and all reasoning and all the visionary things that I told you before, we spent the last 10 years essentially in industry strengthening and productizing this technology so that it can run like the sports section of BBC, which if it fails, there will be 10 million people which will spot it immediately. And this quite requires a lot of attention on what is doable and what kind of features you can combine in a stable and reliable manner, and what optimizations you should avoid. So there are cases in which we don't come first on benchmarks just because there are optimizations and there are features and there are things which are dangerous to do. So we have the chance to work with many of these, the most, I call them knowledge-intensive enterprise on earth. Actually, these are all active clients. That's not the case with some of the other vendors. And yeah, sorry to say this, but yeah, I find it unfair. We can serve a limited number of these clients. So we nowadays work with the biggest IT services vendors, IT services consultants like Fujitsu, Atos Origin, Infosys, Entity Data, whoever else, because that's our way of bringing this technology to big government projects and to plenty of other places where a company of our size can't really serve. So this is like the reference case for which we built our technology, both GraphDBS as a database engine and Ontotext platform, which adds text analysis and then plenty of other features on top of it. And there are plenty of things that don't combine well. And we have to be fair about which features can work with which other features, not to mislead customers. And Peyo, where are you? That's the towboat guy over there. He hates me for this, but I'm the no man. I quite often start a conversation with the client saying, you cannot combine this and this, although you want to have it. no, there are certain features which are not combinable. And you should be crisp clear about it, because otherwise, 6 months later, there will be a problem. So we combine, we build this technology that can deal with big knowledge graphs, with text analysis, with lots of metadata, while at the same time be able to meet all the operational criteria for really critical deployments across the globe. So most of our installations are actually multi-DC installations across all the time zones and stuff, because this is what our clients need. Thank you.
Good afternoon, I'm Arthur Keane with TigerGraph. I've only been with TigerGraph for about 3.5, 4 months. I did spend a lot of my time in the RDF world, some 15, 16, 17 years. And anyways, let me describe TigerGraph to you. You might have some questions of me as to why I moved to TigerGraph, and we can catch that with that later. So, we are much younger than these other graph database companies. We're founded in 2012 by Dr. Yu Xu, and he learned large big data and graph databases in Twitter, and the other founder, Minxi, was at Teradata. We were in stealth for 5 years while these guys built this system from the ground up. So they built a native MPP system in C++ with query generation to C++ from scratch. The backstory is actually quite interesting. While they were doing this, they were working out of their parents' garage in San Diego, and for most of those years. And what is interesting is, in our company culture, is that their parents, being parents, if something moves, feed it, and if it doesn't move, paint it. So they brought in lunch for these guys, and that's in our company culture to this day, that lunch gets brought in. Just an interesting facet of the company. We have won awards. We came out of stealth in 2017, and also got about well over $30 million worth of funding. Up to that point, we didn't have a sales team, we did not have a go-to-market, and we actually had sold to several large, 2 or 3 large companies in China. We're really proud of our Strata award there for most disruptive startup. One thing that's interesting about us is that we tend to work in between the business interface and the consumer, or at the coal face. And part of the reason for that is that, part of the reason for that attraction is that we are real-time capable. So recommendation engines, fraud detection, and so on, where it's happening at the coal face, at that interface between the business and their customers. So, for example, we have customers like Visa, where we do impact analysis on their networks. Intuit, where we do fraud detection. China State Bank, where we do fraud detection and AML. Zillow, where we do recommendation. China Mobile, we do spam detection and fraud detection. Wish.com, where we do recommendation. China State Grid, which is the largest utility in the world. We do, and this is their term, better than real-time monitoring of the entire grid and statusing the entire grid. What we're also doing over there, and this is not we, it's really their solution is they're also running their supply chain on TigerGraph as well, supply chain management as well. Open Corporates recently adopted us. Companies I can't talk about. There's a large, there's a country in Europe that has is using TigerGraph for their intelligence agency, and also other bio companies I can't talk about. Amgen should be on this list as well. So, if you use Intuit, you're a tiger. If you use Wish, a lot of people use Wish.com, you're a tiger too, because you're interfacing directly with our systems. If you're using Zillow, you're a tiger too. If you visit China and use electricity, TigerGraph is behind that as well. Just wanted to point that out. This slide is really about what differentiates us. If you start on the bottom left-hand corner, TigerGraph was built to scale up and scale out. One of our, and that wasn't on the list here, Alipay. Alipay, for example, has a trillion edge graph running TigerGraph. A trillion edge graph is roughly 6 or 7 trillion RDF edges. And our graph is mutable. We can handle 2 billion transactions per second. Real-time performance, we can do deep 10-hop plus analytics for things like fraud detection in 126 milliseconds on typical customers. Ease of development, we have GSQL, which allows you to define your graph algorithms and mappings. Enterprise-grade security, we also have algorithms that are open source on GitHub that are in GSQL. You can copy and modify them at will. Thank you very much.
Thanks.
So we all come with our timers here to make sure that we don't go over our 5 minutes. Right, that's me. So just as I mentioned before, hello again, I'm Jesús, I work for Neo4j. I have this background in the RDF space where I did my PhD. I was talking about that with Atanas before. We met like 15 years ago in Spain in one of the semantic web conferences, European semantic web conferences. So I did spend a few years in a company called Ontology in London that were building a platform for data integration, targeting the telecom space, built on the RDF stack. So, and then from there, I moved on to Neo4j, which is where I am at the moment. So I'm part of also the field team, so I'm helping our customers building solutions with Neo4j. And well, just a few words about us as a company. So we're probably the leaders in the graph space, and we have some numbers here. I would like to just highlight 2 or 3 of them. So we're probably the largest, dedicated investment in graphs, and we're a company that's around 300 people at the moment. But I would highlight that there's 100 of us doing. I mean, I'm not one of them, as I was saying. I'm field, but we have 100 developers, most of them in Europe, in southern Sweden and London, building these graph platforms. So that's a lot of brain cells working to create the best graph platform possible, and they're doing a great job because, as you can see, we have a large number of customers. We have, of course, our collection of logos, as you can see. We're very proud of our community. So you can see that we have had over 10 million downloads of our platform. So we have a community edition that lots of teams are using out there. And we're supporting startups with our startup program. We have over 500, around 700 startups using Neo4j, which probably will be the next Uber, the next Google out there. And we're also doing a great effort in evangelizing. If you look at the number of events, over 400 per year, that's more than the one a day. And that's because we're convinced that even though we all are somehow competitors, our real competition is out there. It's in the people that are still not aware of the fact that graphs can bring amazing value to your organizations. And I think you showed before, how tiny is the graph compared to SQL? They're still, taking over 80% of the market. So that's what we have to fight, and that's we're doing it by among other things, doing lots of events. What else? A little timeline. So I would like to. We started around 10 years ago. So the first GA release was in 2010. We introduced Cypher. We believe Cypher has been driving adoption of Neo4j. Developers love it, and I understand that people will defend Sparkle, and I'm happy with that. We believe that Cypher is going to stay and grow in popularity. We opened it in 2015 with the Open Cypher initiative, and we have organizations joining it. What else? Let me tell you a little bit of. Oh, of course, can't see any. There were some images there, but anyway, some of the things that we care about and that are key in our architecture. So the first one is kind of our secret sauce. It's what we call our native store. So we are a platform that's built from the ground up to deal with graph workloads. And that starts by the way we store data, and we implement index-free adjacency, which gives you this amazing performance when you do traversals, but also give you this predictability. So because we're not scanning indexes, we're chasing pointers, you're getting this kind of future-proof in your queries. We care a lot about data integrity. That's why we are ACID compliant, not only at the instance level, but also at the cluster level. We provide additional levels of consistency, like causal consistency, things like being able to read your own writes in a cluster that are important for graph loads as well. We provide a number of drivers to simplify and help building solutions with Neo4j. And we are extendable platforms. So we offer things like libraries of algorithms that help you building solutions, but it's an open platform, so you can extend it with your own. We have very interesting projects. I've mentioned before things that you've probably heard about, Panama Papers with the ICIJ, the NASA knowledge graph, and many more. So I'm running out of time, so I hope that was a good introduction. Thank you.
All right, well, I think we got 9 vendors and we learned a lot about it, so I think that was already a great takeaway. So I'm going to invite everybody to come sit down here. And that doesn't matter. All right. So we're going to get blinded here. Woo! So before we start into the controversial stuff, I want to just kind of get out it's called the boring things, which is we got a bunch of questions from infrastructure, which is like, tell us about your scalability, your clustering, your replication, your consistency, all that stuff. So let's just go down, if you can all kind of talk about that. Yeah, just go down quickly. I mean, so just tell us more about your infrastructure, how scalable you are, right? High availability, things like that.
So for us, our query infrastructure, the vast majority of our queries run on our custom graph platform. That's really it's using open source Jenna as the Sparkle query engine, and it's using what's called HDT files, which probably very few of you are familiar with, but it's basically a binary serialization of RDF that lets us scale out very cheaply, run exploratory queries across a diverse set of relatively small graphs. When we have deeper graph analytics where you need to kind of load things into a traditional triple store, we do that, and we have actually done that with 2 of the vendors sitting up here, and had deep talks with a third. So our story is kind of the same as a few people up here when you get into some use cases, and then our infrastructure is really built for scale out and high availability across hundreds of thousands of people using the platform continuously.
Okay, well. Yeah, in general, it depends on the type of queries you do, how scalable you can be. Deep queries and a lot of memory. I mean, you're limited in your scalability, but in general, I'll tell customers for a single triple store on a single machine, then anywhere between 2 and 3 billion triples, that's about the end of it. Yeah, really the end of it. But then, if you have like with the Montefiore tens of billions of triples, then you have to go to a clustered approach. So we have an approach where we can shard patient data. Each shard is federated with knowledge bases like terminology systems or PubMed or whatever else you have. And then we have a hybrid query language that does Sparkle. It does both a mix of parallel queries to every shard and the federation with the knowledge graphs. And well, then the sky is the limit. And we're still trying to figure out what the limit is right now.
Thanks. So we offer our clustering solution. I'll focus just on that particular part. So, we call it causal clustering because it provides this additional level of consistency, causal consistency. And in terms of scalability, I mean, our architecture defines what we call core nodes and read replicas, which makes it, unlimited in scale. I mean, currently we don't do data sharding. That's something that's probably in the next release coming. But at the moment, that means that every instance keeps a full copy of the graph, and that's aligned with our idea of, as I was mentioning before, of index-free adjacency. We want to guarantee this kind of predictable performance in our queries. So yeah, that's us.
So HA cluster, strong consistency, ACID transactions, master design, automated failover and replication, all boring engineering stuff. 50 billion edges per Stardog. You can have many Stardogs. We will federate amongst ourselves. We're pretty good at federating queries and virtualizing places that store data, including ourselves. So sky's the limit there. Sparkle can also support linked property graphs through Gremlin. You can use them both interchangeably at the same time. You can have people querying one or the other, both. Multiple data models all at once to give you different views of the data, different perspectives. And we've extended Sparkle in a couple interesting ways, including adding path traversals to Sparkle.
So, hi. Well, speaking of the infrastructure and reliability, we have what we call high availability cluster architecture. And well, we started building this one, and it got proven back in 2010 when most of the vendors around didn't have anything. So we've been maturing this for quite a while in very, very aggressive environments. What is focused for us, like what Neo4j mentioned, is predictability of performance. That's why we don't do sharding, and we don't promise that you can combine reasoning and sharding, and that you can combine virtualization and sharding, because it's a recipe for failure. To make sure that we can scale when we have to, we have integration and we have connectors with full-text search engines so that you can scale up your searches and search performance as much as you want with Elastic or Solr or anything else. And we have connector with Mongo so that if you want to store zillions of objects and documents and metadata somewhere, you can store them there. You can make this like a conscious decision of a data architect and still be able to access them from Sparkle.
So for Neptune, we have strong consistency on the write master of a cluster. The clustering technology that we use provides a shared view of the data across the write master and up to 15 different low latency read replicas. Those replicas have repeatable read consistency, and each of the queries are evaluated independently. So each instance in a cluster evaluates the queries using the CPU and the RAM on that cluster, so you can scale read throughput horizontally in that way. As I mentioned, we support segment sizes of up to 64 terabytes in the storage layer. In our testing, that translates into graphs of somewhere between 100 billion and 200 billion triples, or nodes, edges, and properties in the property graph sense. And then query performance will very much vary. It depends on how much data your queries need to touch to evaluate. And so in general, Neptune is optimized for fast interactive graph queries that are typically parameterized and require low latency graph query answering.
As I mentioned in my presentation, the Datastax Enterprise Graph inherits a lot of the features of Apache Cassandra in terms of scalability and reliability and fault tolerance. So we have many customers that have never had downtime, ever. So like through upgrades, natural disasters, whatever. So there's that aspect. Anytime you shard a database and want to guarantee availability, you have to have guarantees that are tunable. And so you have to say, okay, well, if a server goes down, when it comes back up, you need to get it back up into sync and that sort of thing. And so, but there's nothing like data loss or anything like that, which I think but in terms of operations, I've had a lot of boring Black Fridays where I've been on site 3 in the morning helping debug other people's code and other databases. So if you're looking for that sort of scalable infrastructure that you can rely on, then that's for real time. Well, I guess the last thing I would mention is, as the others have mentioned, I think branching factor and cardinality are an important factor when you're considering expectations relating to kind of SLAs. So if you're looking for a web latency type of experience for a recommendation engine on the web, then you need to do some planning in terms of making sure that you can fulfill those SLA requirements. If you're doing interactive postmortem community-based fraud detection kind of exercises, you might handle that differently. So because you're depending on what you're trying to run. So. it varies.
Yeah, so Data Chemist is an in-memory database, but we do have ACID. We have atomicity and consistency. Consistency is defined in terms of the OWL ontology. So we have a closed world interpretation of OWL, and we use that to prove the consistency of triples that are added to the system. And then a transaction completes in the event that these are consistent, and it gives back a report of information about reasons for failure of consistency with witnesses of the failure, the violation report for that. Then in the case, the durability is through a journaling system. And we scale up to tens of billions of triples on a single machine comfortably. So we use quite a lot of compression in order to do that. And we've paid a lot of attention to trying to make the system as parallelizable as possible. So we make it, our query language WACL is declarative, and so it's easy to do declarative parallelization of certain types of, well, as long as the problem is embarrassingly parallel, you can use parallelism.
Thank you. TigerGraph's built from the ground up to be an MPP system, so it automatically distributes the graph over the nodes. It is also HA, so you can configure it to replicate as well, and it is used in mission-critical situations. One advantage of being built as a graph from the ground up is efficiency. So, for example, our Trillion Edge customer is doing that on 20 machines, a cluster of 20 machines, and they have 2x replication, so another 20, they're doing that on 20 machines. Sizing for TigerGraph, if you're curious, is very easy. If you take 60% of your raw data, your graph plus computations will be in memory across the cluster. As simple as that. Obviously, you can tune for the difference. That's pretty much how we size things without knowing too much about
So, raise of hand, do you guys have integration with Elasticsearch? People were asking. Oh, yes, raise your hand. I was asking about Elasticsearch, so there's the answer. Okay. There's another question about temporal. How do you guys manage time? So knowledge, there's context, and time is the context there. So you guys deal with time and...
Through good modeling?
Sorry?
Through good modeling.
Okay, through good modeling. All right. Simple. Okay. Okay.
Add one thing.
Yeah.
We have this tool, Graph, where you can visualize graphs, and if you model it the right way, and you tell Graph what your time parameters are, you can actually see the buildup of your graphs to time, and you can use it as a time machine. People that are really interested in temporal, you should try it out.
Okay. Yeah, so we have temporal scoping that you can apply to any of the properties or objects in the system, and we use this, in WACL, we have a temporal constraint engine that actually solves the constraints on these things. So you can ask for a time slice through a number of relations or objects, and it will actually solve for when those things existed at the same time. Or it's quite a powerful engine for deciding on time slices.
Yeah, I was just going to say that probably, neither of our platforms kind of out of the box implement like versioning, but it's something that we would do, say, through modeling, and there's a number of...
Okay, there's another question about versioning, so I guess that addresses it too. Yeah. Yeah.
So this is put on my Tinkerpop hat, I guess, for a second. Any store that implements Tinkerpop and Gremlin, there's a method for doing a subgraph strategy to say there is a way to say, give me the time slice. So an energy customer was asking about this, being able to say, give me traverse the graph as though you took a time machine and went back between this time and this time, or this version and this version. Kind of goes to versioning as well. It doesn't have to be time related, but it's often used for time to be able to say, navigate the graph during these time periods or this versions.
So you brought up Gruff, and I know Neo has Bloom and stuff. So another question we had is, what are the offerings that you may have for non-kind of graph technical users, basically for the non-type of, the non-techie users? Is it just Sparkle interfaces on top, or just write the queries, or so please? So Bloom, I know Neo4j has Bloom. You guys have Gruff. AllegroGraph have Gruff.
You can explore graphs by just clicking around in the graph, and then when you see a nice pattern, you just click on the graph, you copy it to the query builder, some of the constant in variables, and you have a query without writing any Sparkle.
Right. Ike.
Yeah, TigerGraph uses Graph Studio, and that's mostly business analyst oriented. You can explore the graph, you can run pre-built queries, and it's about to get a query builder, allow them to basically draw the graph that they want matched. That'll generate the G-SQL for them.
We've got Stardog Studio, which is we call it our IDE for knowledge graph engineers. So lots of Sparkle writing, lots of smart, intelligent completion, adding visualization to it, data browsing. Hopefully we'll be a one-stop shop, but also support like Tableau, for better or for worse. That's enterprise standard in BI, so going where the users are.
And we have a graph browser where you can click around and look through the graph, and with a query builder as well.
Okay, so with all the boring stuff out of the way, now let's get into the interesting stuff. So let's talk about standardizations for a bit, the RDF, property graph, and stuff. So just for some context, there is all this effort around, there's a standardization effort around property graphs, which is this GQL standardization effort. You can go to GQL standard, and it's right now going through the ISO process, so through the same SQL body. And there's this standardization called GQL. So it's going to be the next property graph standard query language, and I think most of you guys are participating in here. Now, I'm going to start this with you, Gavin, all right, why are you presenting another graph query language out here, given that there's already this GQL initiative with ISO? So why another one?
It's a very good question. So we're not married to having our own, bespoke query language. We'd like to have a query language that everybody else uses as well. We'd like to be involved in a standards process. But the fact is that there's a number of things that are just being done wrong, and we feel like they have to be done right first. And so if we put WACL out there, it's going to be part of a conversation about how to go forward with this. And really, the query language has to be built on top of the semantics. You need to have that as the lowest level. And then on top of that, you have the query engine. And I think also temporal constraints in general are going to be necessary for this. It's very hard to do a query across where you're traversing lots of relations in which there's supposed to be some time window, and you don't know what that time window is, and you want to know it exists always at some time window for the entire thing. And how do you solve that? Well, it's not easy with the current systems, and we think it should be easy. It's possible to write something that's easy.
So this GQL is going to happen. So is whatever you're doing going to feed into GQL?
Well, we'll put out WACL, and we'll see, whether or not those ideas, have currency. And like for recursion as well, it has to be treated in a more principled fashion. There's the question of what the semantics of a query is. So in SQL, it's a very clear semantics for what it means to have a statement. Every statement gives back a table. Tables can then be embedded. You have a composability that's very clear. Now, in the graph world, it's a little bit less clear because you have at least two different kinds of things that could be returned by a query. You have graphs and you have tables. And we have to have some way of dealing with the composability issues. Those haven't been treated.
So all of that is being discussed in GQL. Yeah. All of that is being. So, all right, so the question is, for the high-level thing is, and I got a question is, when can I run Sparkle queries over my property graph database? And then when can I run property graph queries over my RDF database? So, Amazon is doing both. I know Cambridge Semantics announced now Cypher support for that. So, will the property graph databases support Sparkle? Will the Sparkle databases support GQL when it comes out?
So just wearing the Tinkerpop hat again, the Tinkerpop engine is agnostic, and so Gremlin is the main language that you interact with to do traversals, but the engine itself is man-years of PhD effort of graph theory in doing optimization and other things over, like bulking and cycle detection and all that kind of stuff. And so in Tinkerpop 4, for instance, you can already compile Cypher, OpenCypher into Gremlin. You can already compile Sparkle into Gremlin, or not Gremlin, sorry. Compile OpenCypher into the Tinkerpop engine or the Gremlin server. And you can compile Sparkle into the Tinkerpop server. And so GQL, or in Tinkerpop 4, I believe OpenCypher is going to be one of the reference implementations for a third-party language going into it, as well as Sparkle And so the nice thing about that is that once you have this engine, kind of like the Java virtual machine, you can pretty much have whatever other language you can.
So, other folks? Oh, AllegroGraph, are you going to support Cypher GQL on top of AllegroGraph? Yes or no? Or I don't know.
Depends on only one thing, if customers ask about it. Yeah, I'm not going to build any new query language that someone thinks of. I mean, that's a very expensive proposition. I wait till we get enough people. We had Shackle, for example, and everyone was talking about Shackle, and then finally there was Shackle. But it takes a while. GraphQL is the next one, probably.
Okay.
Yeah, I didn't hear anyone about GraphQL that much, but
probably not a graph query language. I mean, it's a different thing. But well, I'm going to say, Neo4j's position. We think Cypher has been incredibly successful. Developers love it, and it's been driving, significantly driving our adoption. So we're behind the GQL initiative, and I don't think it makes sense for us to support Sparkle, because Sparkle is for a triple-based representation of a graph. So I think Sparkle is what it is, and it makes sense for it to be there. And we, our strategy is Cypher GQL.
So Bryon, you guys support SQL and Sparkle. What do you support, Cypher or Gremlin or GQL?
Yeah, I think yes. Very very similar to what Jan said, is going to be based on what people care about, what people push. The way that we actually came to the SQL implementation, we talked in the early days about we're going to build the foundation on RDF. We're going to build all of our internal pipelining, data manipulation in Sparkle. It's atomic, it's standardized, it makes for interoperability with a huge number of third parties, so we can actually swap in database engines pretty straightforwardly, and then build everything else as kind of either an abstraction on top of that via transpilation where that's possible, or by building derivative versions of the data that can support other query engines. We hypothesized building on OpenCypher. We'd hypothesized, some of the other graph query languages. SQL was kind of it'd be really interesting to think about what that would look like, and the way we ended up building that, Dave, one of our engineers, he was trying to learn Sparkle to kind of come up to speed, and so had written a parser for Sparkle and a parser for SQL, and basically went home over a long weekend and wrote the first prototype of the transformer that I showed there, and ultimately, kind of like, okay, this is actually tractable. We can kind of quantify what things we can and can't do, and the set that we can do is useful enough that we're like, this is gonna, and I mean, today, if I look at all the Sparkle queries run on our platform, 96% of them are actually SQL queries that got transpiled into Sparkle and run down. But that's had huge value, because that's letting us go interact with people who are SQL writers. They can actually get in there, touch data, start doing things with it. And then when they start hitting some of the walls, we're like, well, actually, just click that button over there and add a new Sparkle query, and let's take your SQL query and start and as a starting point, and go teach you enough Sparkle to kind of do what you're really trying to do. So that's not exactly what you're asking, but I mean, yes, we would support whatever kind of helps people get in there and work with the data.
Jesús.
Yeah. Juan, do you know these tools which are like a fork, spoon, and a knife in a single piece?
Fork.
You have them. But you don't use them too often, right? So I don't believe, I think it doesn't make sense to do Cypher on top of RDF and Sparkle on top of property graphs. I mean, just doesn't make much sense. What makes sense is to have like a GraphQL type of layer which allows you to access different databases, and we are currently developing support for this kind of thing, which is not a query language misleading name, but anyway.
But so something interesting is when you see the NoSQL movement, right? Now, ironically, the NoSQL databases have a SQL layer on top. Do we need to have a SQL layer on top of graph databases to probably help more people use it or not? Because, I mean, it's ironic, I don't know, that the NoSQL now have a bunch of SQL. Yes. So I mean, you guys did SQL over Sparkle. Does anybody else see?
I would almost answer no, because I mean, like I said earlier, like our SQL is not a general purpose. Like if you upload a bunch of RDF data, our SQL is useless on it. It doesn't. It's not unless you kind of go. I mean, you could go create an RDF and layer in the things that let us know that it has a tabular structure. But unless it's got a particular structure, our SQL doesn't work. It's just an artifact of the way enterprise data is laid out, that the vast majority of it has a tabular structure, and there's no reason to lose that because you're ingesting it into a graph.
And I think it almost ends up like a Band-Aid. So it would be something that may maybe help everyone in the short term, but SQL is fast in particular because it bubbles up implementation details. So you have to care about how the data is laid out to effectively maximize a query, the query performance. Is why DBAs are maddening people to deal with. But they help us tune the queries. So if you're kind of overlaying that on top of a graph, and then the expectations end up different because we're different beasts, then you're just going to give people a very poor impression of graph technology because they're going to be expecting something like SQL and not get what they're expecting out of it. And that's like the worst thing we could do as a community, is turn people off and have a terrible first impression by making it easy for them to get started and then have them fail.
Arthur.
Yeah, from TigerGraph's perspective, we built Graph SQL to resemble SQL, to make it easy for the 9 or 10 million SQL developers to use it. Now, in terms of the standards, we're watching both developments on the SQL side for adding property graphs to SQL, and we're also watching GQL. And in fact, we are front-running the GQL, implementing as the standard rolls out. So, for example, in our next release, the property matching capabilities are going to align with what's happening on the standard as well. As far as Sparkle is concerned, customers aren't asking us for that.
I think traditionally, I think when you have whatever traversal language you have, at least over a property graph, there's often the before and after. And so if you're trying to do like 12 nested deep 12 recursive joins, it looks like vomit on your screen, and it's really not very maintainable. So I think in some ways, like you could do the basic queries in SQL, but part of the expressiveness of using the right tool and the right language is to be able to express something simply like a recursive join with various criteria that allows you to do it in a simple and readable way.
Yeah, Jesús.
That's fine. Yeah, no, I don't think SQL makes sense as a way to query graphs, but I'm not against, and I see customers sometimes wrapping Cypher queries as relational views. And the reason for doing that is that there's a whole host of BI tools, for example, that just consume relational data. So the value really is in the fact that you can run some Cypher in Neo4j and you can generate real-time recommendations in single-digit milliseconds. Or you can pick up fraud by doing deep traversals and powerful analysis in the graph. Then if you want to put a layer on top of it that presents it as a table so that you can build a nice dashboard in Tableau, I'm fine with that.
All right, so let's be very genuine and honest about this. So I know people will have the question is, should I use RDF? Should I use a property graph? Should I use Sparkle? Should I use Gremlin or Cypher? So what are the honest, genuine, for this type of use case, you use RDF and Sparkle or use property graph and Gremlin or Cypher, whatever?
Always use RDF.
Okay.
Yeah,
right,
you asked. No, I totally have to agree with that. I mean, there is no, okay. So we had at the beginning of computer programming languages, people were writing assembly, to make things fast, and they were trying to get as much performance as they could. And we went to higher level languages. RDF and semantics are giving us high level languages, and what you want to do in order to get these other features of like trying to have weighted edges, etc., you just disintermediate, make a query language where it's easy to use that, and then it's a data compilation phase if you're trying to eke more performance out of it. It should be thought of as data compilation if we're trying to, really get bang for the buck instead of, honing in on a specific implementation.
So Stardog RDF obviously says use RDF. So Ontotext, AllegroGraph, your RDF. Do you agree with what Stardog said?
Well, almost. Actually, I don't believe that you should. I mean, if your problem is like searching a path in a graph of users of a telecom that are talking to one another, I would not advise you to use GraphDB and any RDF database.
Thank you for being honest and genuine.
But if you deal with master data, metadata, reference data, if you build like a single source of truth within an enterprise, then I don't believe you should go to property graphs.
Jesús.
That's a very simple rule.
I mean, I tried to discuss that in my presentation in my short 20 minutes, but I agree with you. I mean, let me give you my cheeky answer. Use RDF as long as you use Neo4j as your backend. Fine. So, because RDF, as we discussed, is a format for data exchange. change. So it depends what you mean by use RDF. Use RDF means use a triple store, use Sparkle. I mean, I can be RDF. I can produce RDF out of a relational database. You can use Capsenta to produce, you know, RDF views on top of any kind of data source. You guys virtualize all the types of sources and provide an RDF view on it. So this is a very, you know.
Because you want to make it a bit controversial.
Yeah.
If you say that Neo4j is good for like backend for RDF things, you can try one of the benchmarks for RDF systems.
Absolutely, and I can.
Okay, looking forward for it.
Absolutely, and we're busy with real world problems. So that's the thing. But no, sorry, let's not do that. But you know, benchmarks. You know what happens with benchmarks. Any competent consultant will be able to write a query that performs better in Neo than it does in RDF, and the other way around. If you know that, you can.
We both spent like I don't know 6 years, 7 years in linked data benchmarking council. Still waiting for Neo4j to publish
because we're
any
busy
result.
building a great platform. That's the thing. Yeah, I agree with you. And the problem with them. So let me just finish with that. So I'm fully supportive of RDF. I mean, as a data exchange format, that's perfectly fine, and that's something that you can generate on top of any type of store. So the question is, what's your use case, as you were saying? What problem are you trying to solve? And yeah, Neo4j is not about interoperability. We're a data store. We're a data platform to build graph solutions, right? I mean, we're not trying to be, you know, we're not trying to do distributed Sparkle across multiple data sources. That's not what we do.
We are very supportive of people using property graphs for quick and easy dirty start. Yeah. Well, in a database without schema, that's pretty much everything you can do.
All right.
I missed that. So I was yesterday listening to Tom Plasterer from AstraZeneca. They gave a great talk. I heard, because I wasn't there. But he's been doing semantics for a long, long time, and he was talking to a lady that might be here from Benevolent AI, possibly. Anyway, she said, so what should I do so I can, say, work in your infrastructure and benefit from your doing? And what technology should I use? RDF database or Neo4j? And he said, I really don't care as long as you make sure that every entity in your company gets a unique URI and you use a shared taxonomy over your entire company. I don't care what backend technology you use, as long as you adhere to the principle of data sharing. Yeah, and then, so that is really the first thing that you have to care about in your company, not about whether this database or that database, but do I want to be in this culture of data sharing? If you want to be in the culture of data sharing, if you want to do a fraud detection over a very pure graph search, yeah, in memory, mostly, well then use a graph database that is specialized in that. But if it's really about data sharing over a large enterprise, then why would you start with databases that only do...
Okay, just raise of hand. Who agrees with Jans? Okay, okay. Arthur.
Yes, I have to agree with Jans. I think that the choice is really use case driven. There are clearly things that you might want to tackle with RDF and ontologies. And to give you an example of that, if you find, for example, a bank that might have 50,000 or 200,000 databases, and they want to integrate their data and use something like Fiber that has thousands of classes, I think you really want to use RDF to do that. If you want to solve something at the coal face that you need to do fast, you might want to use something.
So Brad, you've been quiet, and you are somebody who represents a community who sees both sides of the world, and you did not raise your hands. You did not agree with Jans. So why didn't you agree with Jans? And then the other question to you is, what you can share is, are more people using the Gremlin side or the RDF side, and for what are they using them?
I mean, I think I expressed my position twice today. But, you know, so I mean, I agree from the perspective that what's really important is effective modeling of your data, thinking about these factors. Do I need to interchange? What kind of formalisms do I want in the semantics? But these decisions are very use case centric, and they're very dependent on other factors that don't relate to the semantics, like what is my development team comfortable with? What does my infrastructure look like? What's the long-term maintainability? How am I going to operate this? So you have to think about all of these things in context, and I think that there's cases where either one, is a viable solution. But I think there's general first principles about, in terms of Tom's point about fair principles that do make sense to adhere to. We need to think about it. So,
do you see some particular, like these types of use cases are always kind of more RDF or other ones property graph, or they're kind of all over the place? It just depends on infrastructure or
if you'd asked me before I worked for AWS this question, I would have said that you should use RDF all the time for knowledge graphs, right? But I've seen customers use property graph for knowledge graphs, and they've been very successful with it, and they have very good reasons for doing it. So, I mean, that's really why I feel like it's not a decision you could take in isolation of the use cases and of the other things in your environment that are going to have the long-term success for, is this going to be a successful system? Is it going to be a system that's evolvable, scalable, maintainable over time? And you have to factor in all of those things. So that's sort of, my position.
Right.
I'm mostly on the same camp as all the people who are saying RDF, so I won't repeat those arguments. But one thing I think is interesting, Jesús talked about this in his presentation. There's a few kind of critical gaps that reification is possible. It's isomorphic to all the things you can do with property graphs, but it's hard and verbose, and it kind of makes for that bad first experience that someone else talked to. So there's a handful of warts on the RDF Sparkle stack that do make it, that honestly kind of engender this argument, because you can often come back to developers have an easier time onboarding to this. This makes sense. This makes certain kinds of expressions easier to onboard, and so I'd really love to see. I'm very supportive of the GQL stuff. I'd really love us to see even improving Sparkle to do some better standards around reification. And I know there's specs out there, but we could see those going to get some traction.
Yeah, and that's the thing is, it is just a word in terms of the syntax. And so there's a simple, query language transformation that can take place in order to make property graph type queries very available to people who are used to RDF world.
So we're going till 5:30, right, Francois? 5:20. So I got 5 minutes left. Okay, so is there somebody who has really pressing questions that wants to ask? No?
Thank you. So my question is it possible to have a way to combine the benefits of a label property graph with a RDF, as opposed to choosing between one or the other?
Oh, we support both at the same time, so yes. It just isn't existence proof. It can be done.
And you can store your data in Neo4j, query it with Cypher, and expose it as RDF. That's absolutely fine. So, yes, yes, of course, and there's.
Joe, just a quick note about how end users want to query a graph. Basically, they want a search bar and type words and get the result. Okay, that's it. And from my point of view, as an end user, the only provider for such a solution is Google, and they do it beautifully. So, how do you compete with them, with Google? I mean, when this use case is asked by the user or the customer.
My point on that is that's a thin slice of the type of use cases, the human, kind of Google-style search. But there is a lot of, automated, API-based access to a graph and queries that need to be structured query language, use of algorithms. So yeah, for that case, of course, we have to deal with that, and we have to provide some easy way, as close to natural language.
So is your database semantic? Yes or no? I know that came up, so let's just go down.
Yes. In 3 different.
So ours is semantic. We
yes.
can pull in RDF and we can create conceptual graphs.
Okay.
Yeah,
Yes.
100%. We have something called frames, so we return JSON LD structures that tell you about what the data type was, so that you can constrain things and build user interfaces based on that information.
Jeremy, is your database semantic?
From my understanding of what that implies, I believe that it's functionally equivalent, but you have to build that in yourself.
Okay.
We support RDF 1.1. We support Property Graph Tinkerpop 3.3 currently. We do not support in-database inferencing today.
Yeah, the short answer is yes, we do support reasoning. We took care that you can do reasoning in all ways you need in these kind of applications. And nowadays we go towards distributed semantics.
Yeah, I'd say we're not only a semantic system, but we also apply that semantic layer to things that are not like Oracle or Mongo.
Well, I like to say that this semantic term is so overutilized.
That's why I use it loosely on purpose, because I want to see what you guys have said.
I've talked about that several times. I mean, what I consider semantic is, can you and do you make your semantics explicit in your database? Because if you're using RDF, but you're not creating an ontology, are you being semantic? Maybe you are, maybe you're not. I mean, that's a debate. So yes, you can store an ontology in Neo4j. It won't be represented according to, you won't be doing standard OWL reasoning, for example. But yes, you can express explicit knowledge in Neo4j.
Jan, I guess yes.
Well, at the core, AllegroGraph is just a tuple store, and then on top you can model whatever you want. So actually, and I bit my tongue several times today, so I'll have to let it out anyway. I can very easily, using the fourth element of triples, just model property graphs. Actually way better, because the values of my attributes can be other objects, and I can make meta-statements about meta-statements about meta-statements. I can even do hypergraphs, yeah? I can have from one connection point to multiple objects. So in that sense, it's kind of a silly question. I just want to go back to my earlier answer. You have to make the really big decision. In my enterprise application, yeah, am I going to have the discipline to give every object that's important in my business the same name? And that's it. And do I use a common vocabulary? But yes, we support the...
Yes, everything we just RDF and let you embed ontologies. Since this has become kind of a conversation about inferencing, I'll say our standard query layer can do basic RDFS inferencing in some of the elements of the lower levels of AL, but we don't kind of turn on full inferencing in that layer. When we can forward chain a lot of those things for bulk loaded things, or when you want to turn on higher levels of inferencing, we bring in another triple store that supports that natively.
All right, so I know we need to wrap up. So this is the last question, and I know everybody here in the room is probably saying, well, I'm looking into graphs. I have now 9 different things I could test, right? And I only have a finite amount of time to go test. So you're on an elevator for 1 or 2 floors. What's your 1 or 2 elevator pitch of why people in this audience go use your platform database? So when we go down, and with that, we wrap up. So
you can go create a free account right now and log in. You can bring in some RDF data and query it with Sparkle. You can bring in, drop in a CSV or an Excel spreadsheet and query it with Sparkle or SQL. You can look at the hundreds of thousands of open data sets we have out there.
All right, Jans.
Just go download a free version with our visualization tool Graph and start writing your own Sparkle queries without writing any Sparkle.
Right, so I would say if you want to get started quickly, if you want to download a platform that will get you running in a matter of minutes, then go download our desktop, and you will get a platform that protects your data, that cares about the integrity of your data, and that gives excellent performance for all sorts of graph workloads.
Right. Mike?
Go to our website, grab Stardog. If you don't want to install it, everyone says the same answer. If you don't want to install it, there's a hosted sandbox version. Stardog Studio is included. If you want to just run it on your machine, you can grab Stardog and Studio separately. If you don't have data, that's fine. Just connect us to whatever in your org does actually have data. Surely there's data somewhere. You can be up and running in an hour.
Yeah, okay, if you need an enterprise knowledge graph platform without engineering shortcuts and without promises that cannot be met, use Graph Database, GraphDB. Thank you.
If you want to choose RDF or property graph, and you also don't want to set up your own high availability configuration or deal with encryption at rest or read replication, try out Amazon Neptune.
If you want a highly scalable, highly available, always available data store that does graph operations very simply, you can go and download there's a Docker image and get set up like that.
Later this year, you'll be able to download our Terminus DB open source offering, and you get to play around with a temporal constraint engine and see how it can help you to solve problems that are not easy to solve with other ways. And you can also soon, later this summer, we'll have access to our online SAS ontology builder, which exports to OWL.
We verified that our customers can download and finish our 101 G-SQL within an hour. Docker, on AWS, or on the laptop. If you don't want to download it, you can. We've got a number of demos that you can play around. Those demos are not toys. They have 4 billion edges each, and billions of vertices.
Right. So that means that you need 9 hours to go spend on each one. With that, thank you guys very much. We really appreciate it.